Okay, the stream kind of died. I think it's back now, hopefully. Um, yeah, hopefully it works now. Okay, yeah, my internet is acting up right now. Okay, I think we're good. So basically, the way it's gonna work is you will have some sort of label here, right? So just a label. Um, hang on. There we go. So yeah, we'll have a label here. It can be anything. And then here we can do stuff, push 5, whatever, push 6, add, and then you return from the label. So then down here you would have like the main, for example, and you can do whatever, and then you're gonna call the label. And basically what it will do is we'll perform a jump to this label. But the important thing is that differentiates it from a jump is basically it will push onto the return stack the current instruction pointer, right? Well, actually plus 1. So like whatever you have here would, so it'll start from there. Basically, that's what it's going to do. And then when it comes up here and when it gets to return, it'll pop off the top of the return stack, and then it will start going from there. So that's basically what we're doing now. So we need to implement, actually I can leave that for example purposes. Basically we need a return stack. So that is going to be stored in the machine, the virtual machine itself. Yeah, so right now we have a couple different stacks in here. Let me move this actually so it is, there we go, and then we will have, so it can just be an int, I think. I don't think it will go beyond that, or maybe a size t would be better. Yeah, because it's not going to be negative ever, so we'll do that. And then this will be return stack, and max stack size. And then we will also have the return stack size, much like this. Yeah, and so then we need 2 new instructions. So I'll put it just before the jumps. So basically we need inst call. So that is the call instruction, which is similar to jump, but obviously it's not exactly the same. It's more calling a function. And then we also need the return. So that could probably go right before here, or maybe right after. Doesn't really matter, but just for thinking purposes. Yeah, so call and return. So those are the keywords that we need. So I think we'll implement it in the virtual machine, and then we'll add it to the assembly. That's the wrong one. Okay, so we'll add it in here. So what we need to do, when we encounter call, we want to push the current instruction pointer. Well, actually, the current instruction pointer plus 1, and then we also need to jump to whatever is being called, the index. So yeah, I'll add it down here. So right before the jumps, let's see. Yeah, right here. So yeah, we will have case inst call, and then case inst inst return. Okay, so yeah, we'll do call first. Yeah, so we need a way to work with the instruction stack. Right, so we're gonna do machine return stack, rather, not instruction stack. Return stack. Yeah, so, and then machine return stack size plus equals IP, basically. That is what we need. And then we want to jump, so perform a jump in the same way that we do this. So in a regular jump, this is what we do. So basically, whoops, we can do the same thing that we are doing right here. And I'm not sure if we need that -1. I don't remember why I did that, but we'll figure it out. So machine instructions IP.value, okay. And interpret it as an integer, that's all good. Basically, that's what we're going to do. And then when we encounter return, we're going to do machine return stack size equals, well, actually, we're going to set IP equal to that, basically. And I think that is all that we need to do. So that's basically pushing and popping off the return stack. So I'm pretty sure that's what we need to do for this. So now we can implement it on the level of the assembly, and then we can test it out. So in the lecture, we will add the types for it. Yeah, so right here, both of them. So we'll have type call and type return. And then we'll add the keywords into, actually that's in the .c file. If I can spell, .c, there we go, that's the one that we want. Let me find where it's at, this one. So we can add it in here, in the same place. So let's see, right before the jumps. So we will have call and ret. Whoops. There we go. Okay, so now that should add the keyword. So I think that's all that we need in the Lexo. So, yeah, so now we can do the TASM. Actually, is that all that we need? Yeah, so that's it. So now we can look in the parser. And in here, if we can basically treat it the same as a jump. So it could have a label or an integer following it. So let's see, where do we have jumps? So this is, here are the jumps. So let's actually put it first since it comes first. So we'll do type call. Yeah, so the type call is handled the same. So let me just do that. Okay, type call. It'll work that way. And then the return doesn't have any keyword. So that is going to be treated more like, let's see. So there's not going to be a keyword after it. Which other one? Yeah, so I think that, yeah, we don't need to actually handle it in here because it'll just automatically be handled. Yeah, so that should be good. And now we can actually implement it on in the assembly. The actual, that was kind of messy, but okay. Oh yeah, so we do need to add this in here. So wherever the jumps are, right here. So then we'll add inst call and inst return. There we go. And then, so here we can do the same thing as this. Yeah, this could be a bit cleaner, but head value dot type equals type yeah, type call or that. Okay, so that should be good. And then yeah, we're setting it as int because it can only be an int following it. Because the labels, once they get processed, they're converted to integers. So that should be working fine now. Yeah, I think we're good in terms of that. So let me see if it works now. So actually, we still have the test. So test.asm. Whoops. There we go. Okay, so we have the label here. Add, return, and then on the top of the stack it should be the add effect. So this can actually just be print. We'll print what's on the top of the stack, basically. So if we build this, alright, there's no errors actually. That's kind of surprising. Test.tasm. Alright, expected non-type, but found label. Okay, so on 1.1 label. Okay, so it doesn't like this. Why? Not sure. Alright, so I guess we can't name it label. I mean, test.tim. Okay, so it didn't do anything because we actually need to jump to main first. And then, okay, so as int 11. Alright, so that seemed to have worked. So I'm assuming it did work. So we can actually print it here. So call stuff, and then, yeah, when we print at the end, it should be stack underflow. Yeah, so I think it's working. We can make sure it's working by actually checking in the virtual machine. When we encounter a return, we can just printf IP, just like that. Actually, let's see, is it, I don't remember what it is, but okay, let's see. So it is a size D. Okay, so we can alright, size T. So I'll just change that. There we go. Okay, and then we'll run test.tasm.tim. And okay. So we didn't actually print it. Okay, so alright, weird keyboard stuff. So it did not print it here on the return. Alright. Build it and then run it. Yeah, it doesn't want to print it. So, are we not ever actually calling the return? It seems to be so. So let's actually go into the different stages. So we'll go into the parser first, and we'll just print the list. So that's what we've got right here, and we'll see what it says. Test.test. And do we have a return? So we do have return. Type none, no. Okay. Return, and then, yeah, so that should be fine. So it looks fine on here. Then do we not ever set it in here? Yeah, so in here, yeah, so it doesn't have an operand, so we don't need to worry about that. Can we? Let's just check. Basically, if head value, value dot type equals type return, then printf ret. And we'll see what it says for that. So let's actually try that out. Okay, so we do have a ret. So it should be adding it. And then it should be working. So let's change it so it's not a stack underflow, just like that. And then we'll just call native native 60. One native 60. There we go. And then we'll recompile the whole thing. It didn't work actually. So jump to main, call stuff, and then it does all this. Oh, because we add, there we go. So that needs to change. There we go. Okay, so now I think it's working. So if we go into the tim.c again, and here we print it with more information. So basically, current IP equals that, and then build it, and test.tim. Okay, so why do we encounter it twice though? That's obviously an issue. Okay. Let me run this and then echo that. 1. Okay, so let's change. Let me just make sure it is actually that. And there we go, and echo that. 11. Okay, so that seems to be working fine. So yeah, we're actually running it twice for some reason. So when we return, I must be doing something wrong in the logic. So, actually, does this need to be like this? Okay. Yeah, so that actually is better. So I think that was the issue. Yeah, because we were doing that twice. So now if we run this, just to make sure that's not in, current IP equals 6. So that, let's see, that's not particularly useful. But so it should go to there. Okay, so I think it's working. So then if we try to print here, then it should not work. That's not as in. Fire test.tim. Okay, stack underflow. So that is what we want to see. So basically, now we can build recursive things rather than just iterative things. Because we can call it in the similar way that you would call a function, right? Like you would call func, like that. And then return is obviously just a return. So there's not arguments to it because those are just stored on the stack. So basically you're going to push to the stack whatever the arguments of the function are, and then you're going to modify it there, basically. So yeah, I think that should all be working now. So let me just make sure we are, we're going here as well. So, so actually, do we need to make this IP plus 1? Okay, so it still works like that, but is it working better? No, actually, that's not right, because it does skip this one. So, yeah, we want to just make it IP. Yeah, and then IP gets iterated actually. So yeah, that's how we have to do the -1 there. Yes, that should be fine then. Should be fine. So yeah, because we actually do handle it here by not subtracting from it. So it gets iterated. Alright, so that's all good then. So yeah, now we have call and return keywords. So we can build some pretty cool stuff now. Yeah. So I think something I want to do is actually add something where you do entry point and then you type the name of whatever label you have that is the actual entry point, which basically just means the same thing as jump main, but it's a bit more more formal, if you will. I suppose that's a way of putting it. So is that, and then when we actually build the program language on top of this, basically what it'll be is that will be default. Like how in C you have entry point main by default, so you have to have a main function. If it's in your main script, that's sort of how that will work. But you can only have one of them, obviously. So I think that is a good idea. So to add that, it would only be on the level of the assembler. It wouldn't be built into the virtual machine at all. So so I think we can just add a new type down here. So it's basically like a label. So basically type entry point. And that would just be followed by a label. So maybe I'll put it right before it. Actually, I messed that up. Put it right before the label. And then we can add it to here as well. So right in here. Yeah, right here. We'll not completely mess that up. Let me get rid of that. And then, yeah, so basically, whoops. There we go. So this will be entry point. And then we have that keyword now. So in the parser, we need to make sure it is followed by a label or it could just be an index, I suppose. So, actually, yeah, so that should be fine. So let's see. So whenever we have a, let me close this. There we go. It's getting in the way. Basically, it'll be the same as this. So, type entry point. Then we're going to do that and make sure it is int or label. Yeah, so that's all good. And then in TASM.c, if we encounter that type, we'll just change it to a jump. And that's basically what we need to do. So, if head value.type equals type entry point, then, yeah, then we are going to do that, basically. So, I do need to add that into here as well. So that comes, let's see where I put it. Actually, I don't need that here because it's not part of that. So basically, then we'll set instruction type equal to type jump, and then we'll just handle it in the same way as that. So basically, head equals head next, and then instruction value dot as int equals apply head value dot text. So actually, we have this get served, and that actually works the exact same as this. So it's just literally being repeated because it's the same thing. So I think we can add that into here. So or type native, yeah, or head value dot type equals type native, or head value dot type equals type get served. Yeah, and then we can just get rid of this entirely because it's literally the same thing. So this one needs to be changed because we are changing the actual type to a jump. So that is good then. Okay, so let me build this. Alright. Oh yeah, so we need to change this actually to an instruction jump instead of a type. Inst jump, like that. Now if we build it, alright, so now we should have the entry point. So test.tasm. Alright, so that didn't work. Oh yeah, so that is actually up here. So we need to set it actually before this assert. Okay. Yeah, so we'll actually just move this one to be pre-assert. Alright, actually, right there. There we go. Because that is protecting that, but if it's this, then we change it to jump. So, that needs to be instructions. Instructions. There we go. No, because we don't define the instruction until after that. But we can easily Alright, that's actually not going to work. So I think what we'll do is we'll just do it in the parser. Basically, if we encounter a type entry point, basically if expect token, Lexer index 1 type entry point, then we'll basically just set the current token. Yeah, we'll set the Lexer token stack index equal to type jump, and then it should call this down here actually. So we can get rid of that one. 1, 2, 3, 4, 5, 6. Yeah, so that should be good then. And then it should just set it here. So that is what we need to do. So we don't need to check for this anymore. And then, yes, we need to change the dot type, not just the actual token. And now if we call this test.tasm, alright, so it didn't work. Okay, so it didn't change the type, it looks like. Let's print token, Lexer token stack index, and let's see what we get. Tasm, test.tasm. Alright, so entry point. And let's print it afterward. And it's still an entry point, so it didn't actually change it. Okay. Okay, so what can be done about that? Okay, so I suppose, if we do, if we call this append, because we aren't actually calling that in here. And that, index, so it's type jump, okay. And then, index plus plus, and then current token equals Lexer token stack index. And then, okay, we'll just grab this. And then, yep, so that's the same thing, and it should work then. So it still doesn't work. It's not changing the token. So why doesn't it want to do that? So let's do token stack index. So I'm not sure. Then at the end we don't have any append. So let me yeah, so let me print the token then. Lexer token stack index. So I don't understand why this won't change that. Yeah, it just stays an entry point. So oh, but it keeps the text as entry point. Okay. Yeah, so let me see if, I don't think that should matter, but basically Lexer token stack index dot text equals, yeah. So let's just do that. And then, there we go. So it still fails, but yeah, so it is actually changing it. That is good. So, we don't need the print token anymore. And then in here, yeah, so let's actually print the widths right here. Build that, and then we'll see what it is made up of. So, I'm assuming it's the first one that fails, where we have, yeah, so it still is entry point, so it doesn't update it. So perhaps this needs to be on the Lexer. Hmm. So what do we do here? Oh, okay, so this actually is doing that. So we need to do it before that, right? Okay. Yeah, we need to do if open Lexer index 1 type entry point. Then we'll do Lexer token stack index dot type equals type. Yeah. Alright, so let's do that. And then, yeah, then we can get rid of this as well. So let me set this here. And then we can get rid of this and it should become jump. So, actually it won't become jump there. So we need to handle that still. So, because it's expecting the next token to be that. So, let's see, did it, so it did work, it looks like then. Okay, so that seemed to work. We have the stack underflow, and that's because we're calling this print here, so let's get rid of that. Let's type in, okay, and echo that, and it worked. Okay, so, that is good then. Yeah, so I guess that did work now. Let me get rid of this, print list right here. That's actually in here. Print list right here. We can, get rid of that. There we go. Alright, so rebuild it and then run it again. Okay, and that seems to be working. So now we have function calls and entry point. The thing is though, since it just converts to a jump, it has to be defined first thing. Must be defined first. Yeah, but now I think I should make an example using calls, basically. And that will also test to make sure it works. So actually I can delete all that. Let me quit out of that, and then remove test.tasm as well as test.tin.